Hello, today we're going to talk about the equation of a line. So the first thing that we want to review is the properties of lines. So the first property that we are going to talk about is the gradient. The gradient is the measure of a line's steepness, okay? And that is found by taking 2 points. Let's say we have 2 points, x1, y1, and then we have another point, x2, y2. The gradient is found by taking your change in y and dividing it by your change in x. So if I write my change in y's on the graph, it will look like this. And then I will also write my change in x. Okay, so basically I'm just subtracting to find the difference of the two changes in x and y. And then I will need to divide them. So the formula for the gradient of a line is going to be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, which is also known as rise over run, and it's also known as the change in y over the change in x. So as you can see from those three fractions here, you should see that the gradient is also known as what we have been calling the slope for many years. So the next property that we're going to look at is the y-intercept. The y-intercept of a line is the point where the graph touches the y-axis, and the x value of the y-intercept is always 0. If I were to denote the y-intercept on the graph above, it will be denoted as 0, comma y. The x-intercept is just like the y-intercept, but it's in reverse. And the x-intercept is the point where the graph touches the x-axis, and the y value of an x-intercept is always 0. If I were to label that pink point on the graph, which is the x-intercept, I will label it as x, comma 0. So now let's talk about parallel and perpendicular lines. Parallel lines have the same gradient or the same slope. Perpendicular lines have opposite reciprocal gradients. And remember that the words opposite reciprocal means to change the sign and flip the fraction. For example, if I have a line that has a slope of positive 3/4 or 3 over 4, the perpendicular line to that line will end up being a negative 4 over 3. You also should recognize that or remember that perpendicular lines form 90-degree angles or right angles. So now let's talk about the equation of a line. So the equation of a line represents the relationship between the points on a line. There are three forms that we are going to use in this class. The first form that we are going to use is gradient-intercept form, or in other words, slope-intercept form. That is given by y is equal to mx plus c. Now, in your previous math courses, I'm pretty sure that you have heard y is equal to mx plus b, okay? It does not matter. They are both the same, okay? The reason why we use the letter C is because C normally is the letter that we use to represent a constant. A constant is a number that does not change or is a number that does not have a variable attached to it, okay? When we use gradient intercept form, we have to understand that M is the gradient or the slope and C is the starting point or the y-intercept. It is best to use gradient intercept form when writing equations of lines when you are given the initial amount or the y-intercept, and you are also given the slope or the rate of change, which is also known as the gradient. The next form that we have is what we call point gradient form. Okay, the point gradient form of an equation of line actually comes from the gradient formula. Okay, so basically all we have to do is take the equation m is equal to y2 minus y1 over x2 minus x1, and we just solved it for m. And you will also notice that you don't see a y2 and an x2 in this equation. You just see x and y and an x1, y1. It is fine. The only reason why we use the ones and the twos is so that we can keep the x values and the y values together that are supposed to be together instead of interchanging the values of the coordinate points. So, because we derived the point gradient form from the gradient formula by solving it for m, we also should understand that the point gradient form is best used for writing equations of lines if you are given a point on the line, which is always going to be denoted as x1, y1. That is what your given point will be substituted in for. And you are also given the gradient. That is why it's called point gradient form. If you know the gradient and you know the point, put it in point gradient form. Just like gradient intercept. If you know the gradient and you know the y-intercept, put it in gradient intercept form. The last form that we have is general form, which is ax plus by plus d is equal to 0. And a, b, and d have to be integers. Remember, integers are positive and negative whole numbers. And it is best for using it to find the x and y intercepts. So now let's talk about special lines. So there are two types of special lines that we have. We have vertical lines and horizontal lines. So vertical lines are lines that go up and down, okay? And the equation of a vertical line is always in the form of x is equal to c, where c represents a constant or a number that does not change. Whether it's a fraction, a whole number, a negative number, it's just a number. All right, so let's look at an example of a vertical line here. I have this blue vertical line drawn, and if you were to imagine, or if you were to plot a bunch of points on that blue line, you will see that they all have the same x value. The only thing that changes between those points on that line is the y values. So because of that, we can say that the equation of this line is x is equal to negative 2, because we know that no matter what y is, x is always going to be negative 2. Horizontal lines go from left to right. The equation of a horizontal line is written in the form of y is equal to c, where c is a constant. An example of a horizontal line is given here. So if you look at this blue line, you will see that no matter where you plot your points on that blue line, you will see that the only thing that changes is the x value. Those points on that blue line will all have the same y value. So because of this, I can say that the equation of this horizontal line is that y is equal to 3. All right. So now let's look at a few examples. Example 1. It says find in gradient-intercept form the equation of a line with a gradient of negative 4 that passes through 5, negative 6. So the first thing that should stand out to you is that they told you to find in gradient-intercept form the equation of a line. So remember, gradient-intercept form is y is equal to mx plus c. So I want my final answer to look like that. The next thing you should notice is that they gave you two pieces of information. They gave you the gradient or the slope, m, and they also gave you the point, 5, negative 6. Anytime you are given the slope or the gradient and a point, it is best to use point gradient form. If you want to use gradient intercept or slope intercept form, you can, but it's just a little bit more work that we don't have to take the time out to do. So we're going to start off by using point gradient form. And remember that your gradient is negative 4, so that means that m is negative 4. And the point that we have that's on the line, or that the line goes through, or the given line, is 5, negative 6, which means that 5 is going to be x1 and negative 6 is going to be y1. So now all I have to do is substitute that information in. So I'm going to have y minus negative 6 is equal to negative 4 times x minus 5, and then close my parentheses. So now I then want to reduce and simplify. So next I will end up having that y plus 6. Remember, a negative and a negative is a positive. So anytime I have subtract negative 6, that's the same thing as adding 6. That is going to be equal to negative 4 times x is negative 4x. Negative 4 times negative 5 is a positive 20. So as you can see, I'm getting closer to the form that I need to have it in. So now I just need to do the final step, which means to get y by itself, which means that I need to subtract 6 on both sides. If I subtract 6 on the left-hand side of the equation, then I'm going to have y equals negative 4x. And then remember, if I subtract 6 on the left, I have to subtract 6 on the right. So that means I'm going to end up having 20 minus 6, which is a positive 14. So this is my equation in gradient intercept form. Example number 2, it says write the equation y is equal to 3/4 x minus 7 in general form. So remember, general form is when you have ax plus by plus d is equal to 0. And remember that a, b, and d have to be integers or whole numbers, no matter whether they're positive or negative. So the first thing that you should see here is that you first have to set it equal to 0. It does not matter if you take everything from the left and then move it over to the right, or you take everything from the right and move it over to the left. You will get the same answer, okay? Both equations will be equivalent, okay? So I am used to getting everything on the left-hand side because I like having equals 0 instead of 0 equals. So I'm going to subtract 3/4 x on both sides, and I'm also going to add 7 on both sides. So when I subtract 3/4 x on the left-hand side, it's going to give me a negative 3/4 x plus y, because the y stays positive because it's still on the left-hand side. I did not move that. And then if I add 7 on both sides, that's just going to be plus 7 is equal to 0. So now that I have everything equal to 0, I then need to make sure that I have all integers or whole numbers. So I see that I have negative 3/4, so I need to get rid of that division. And the opposite of division is multiplication. Just make sure you understand and you remember that whatever you do to one term, you have to do to all terms. So I need to multiply the entire equation by 4. So when I multiply my entire equation by 4, I know that 4 times negative 3 over 4 is negative 3x. And then I have 4 times y, which is positive 4y. And then 4 times 7 is a positive 28. And that's going to be equal to 0. Now, let's say if you were to do your first step as subtracting y on both sides, getting everything over to the right, you will still get an equivalent form, okay? So if we were to start off by subtracting y from everything, we would have end up getting 0 is equal to 3/4 x plus y minus 7, and then we would have to multiply all of that by 4. So if we were to do that, we would have ended up with 3x minus 4y minus 28 is equal to 0. Okay, or you will have 0 equals 3x minus 4y minus 28 is equal to 0. They're the same thing. As you can see here, both of these are equivalent forms, meaning that I can get from one equation to the next equation by doing something to the equation. So in order to get the top equation to get to the bottom, to take the top equation and then turn it into the bottom equation, I'm just multiplying everything by -1. Whatever I did to one side, I did it to the other side, which means that they are equivalent expressions. All right. So part B, or example 2B, it says we want to write the equation 6x plus 14y is equal to negative 21. We want to write that in gradient intercept form. So remember, gradient intercept form is y equals mx plus c. So all I have to do is just solve this equation and solve it for y equals. So I'm going to start off with the equation, and then I need to get y by itself. So y is on the left-hand side, so I'm getting everything that's on the left-hand side that does not have a y in it. It needs to go to the other side. So I'm going to subtract 6x on both sides, which will end up leaving me with 14y is equal to negative 6x minus 21. If you had 14y is equal to negative 21 minus 6x, it is the same thing. But normally in mathematics, we write the x term first because we have y equals mx plus c. All right. So then I need to divide everything by 14. So I know that 14y divided by 14 is y equals. And then I'm going to have negative 6 divided by 14. And if I put math enter into the calculator, I will get negative 3 over 7x. And then I have negative 21 divided by 14. If you don't remember how to simplify fractions, use the calculator. And that will be negative 3 over 2. So this is my equation in gradient-intercept form. Example number 3. It says we need to find the equation of the line with a gradient of 3/2 that passes through -5, -4 in general form. So remember, general form is ax plus by plus d is equal to 0. So once again, we are given the gradient and we are given a point. So it's easiest just to start with point gradient form. So if my gradient is m, I know that m is equal to 3 over 2. I know that I'm given a point. So because I'm going to use point gradient form, I know that -5 is going to be x1 and y1 is going to be -4. So now that I have that, I'm going to substitute those values into the point gradient form here. So I'm going to have y minus -4 is equal to 3/2 times x minus -5. So then I'm going to simplify. So I know that y subtract -4 is the same thing as having y plus 4. And that is going to be equal to 3 over 2 times x. And if I have x minus -5, that's going to be a plus 5. All right. So now that I'm here, all I have to do is distribute. So now I'm going to have y plus 4 is equal to 3/2 x. And then I have alpha y equals, to put it in fraction form, 3 over 2 times 5 is 15 over 2. So I have plus 15 over 2 there. So that is my next step. So now what I want to do is I want to get everything to one side. Remember, we are focusing on general form. So that means I need to subtract either y and 4 on both sides, or I can subtract 3/2 x and subtract 15 over 2 on both sides. I'm going to get everything to the left-hand side. So the first thing that I'm going to do is I'm going to subtract 3/2 x, which will end up giving me -3/2 x on the left-hand side. I am not going to touch the y, so that's just going to come down as plus y. And then I'm going to subtract 15 over 2 on both sides. So if I do 4 minus 15 over 2, I end up with -7 over 2. And then that is going to be equal to 0. So now that I have it equal to 0, I then need to multiply by 2 for everything. And then I know that 2 times -3 over 2 is -3. And that's going to have an x on it. And then we have 2 times y, which is 2y, or positive 2y. And then we have 2 times -7 over 2, which is just -7. And it's still going to be equal to 0 because 2 times 0 is 0. So this is my equation in general form here. Your equation, if you had subtracted y and subtracted 4 on both sides, meaning that you got everything to the right, your equation would have been positive 3x minus 2y plus 7 is equal to 0. Either or is correct. Okay. All right. So let's go over example number 4. Example number 4 that says that we need to find the equation of a line that passes through the points 3, 2, and -2, 6. It did not specify which form I need to use, so that I'm just going to show you how to do all three. So the first thing that I would need to do is I would need to find my slope. And we should know that your slope is equal to your y2 minus y1 over x2 minus x1. So I'm going to type in the calculator, alpha y equals 6 minus 2 over a negative 2 minus 3. So I will end up getting negative 4/5 as my slope. So now that I have my slope, I can use the slope in one of the points. It doesn't matter which one you use, I'm going to use 3, 2, and that's going to be my x1 and my x1 and my y1. So once I have that, I'm going to put this in point gradient form because that's what I have. I have a point and I have the gradient. So I'm going to plug in these values into point gradient form, and I will have y minus 2 is equal to negative 4/5 times x minus 3. And then I will already know that if I wanted to stop there, I am fine. This is the equation in point gradient form. However, if I wanted to turn this equation into gradient intercept form, I would have to distribute negative 4/5, and that will end up giving me y minus 2 is equal to negative 4/5 x plus 12 over 5. And if you needed to, you could do it in the calculator. Negative 4/5 times negative 3, that's where the positive 12 over 5 comes from. And then we will have to add 2 on both sides. So if I take 12 over 5 and I add 2 to it, I will end up getting the 22 over 5. So I will have y is equal to negative 4 over 5x plus 22 over 5. This is my gradient intercept form. Now, if I wanted to put this in general form, all I would have to do is I would have to set it equal to 0. So I'm going to add 4/5 x on both sides, and I'm also going to subtract 22 over 5 on both sides. And when I do, I will end up having 4/5 x plus y minus 22 over 5 is equal to 0. Remember, the y does not change signs because it stayed on the left. It did not move. So then I will have to multiply both sides by 5. And when I do that, I will end up with 4x plus 5y minus 22 is equal to 0. That is my general form. Or, depending on if you subtracted y in the beginning on both sides, you would have ended up with negative 4x minus 5y plus 22 is equal to 0. Either or is the correct general form. So now if we look at example number 5, it says determine if the point lies on the line with the equation. If a point lies on a line, that means that if I substitute that point in for x and y, it's going to make the linear equation true. So all I have to do is substitute in negative 3 for x and negative 4 for y and see if the left side equals the right side. So when I do that, I will end up getting negative 4 is equal to negative 3. Be very careful there. You're changing your x is negative 3, not negative x. All right. So I'm going to have negative 4 is equal to negative 3. And then that's going to be minus 6. And if I simplify, I'm going to end up getting negative 4 is equal to 3 minus 6. 3 minus 6 is negative 3. Negative 4 is not equal to negative 3. So it is not on the line. I do the same thing for B. So for B, I would have to substitute in 3/4 for x and 5 for y. So I would have 8 times 3/4 minus 2 times 5 is equal to negative 4. And if I substitute all this into the calculator, I will end up getting negative 4, and negative 4 is equal to negative 4. So if negative 4 is equal to negative 4, I already know, yes, this is true, and this does lie on the line. All right. Last but not least, example number 6, it says find m given that the equation of a line is equal to y equals mx plus 5, and it goes through the point 3, negative 2. If I give you a point, plug those values in for x and y. So when I do that, my equation will end up being negative 2 is equal to m times 3 plus 5, which is the same thing saying negative 2 is equal to 3m plus 5. I need to subtract 5 on both sides, which will end up giving me the equation negative 7 is equal to 3m. And then I will have to divide both sides by 3, which means that m will be equal to negative 7/3. If I repeat the same process for B, it says find k given that k negative 11 lies on the line whose equation is 9x plus y is equal to negative 13. As you can see, k is in the same place that x is. So I'm going to replace x with k and y with negative 11. When I do so, I will end up getting 9k plus negative 11 is equal to negative 13. If I add a negative 11, that's the same thing as subtracting 11. So I will have 9k minus 11 is equal to negative 13. I will have to add 11 to both sides, which will end up giving me 9k is equal to negative 2. And then I will have to divide both sides by 9, which will end up telling me that k is equal to negative 2 over 9. So now let's talk about graphing a straight line. If you are going to graph a straight line in gradient-intercept form, you need to plot the y-intercept, and then you're going to use the gradient to locate other points on both sides of the y-intercept, and then you're going to connect the points with a straight line. When you use your gradient, you're using rise over run. All right? Remember, if your gradient is positive, your line should be going up from left to right. If your gradient is negative, it should be going down from left to right. If you have an equation in general form, you're going to find the y-intercept by setting x equal to 0, and then you're going to find the x-intercept by setting y equal to 0. Once you have those x and y-intercepts, then you can connect them with a line. So, for example A, it says, draw the graph of y is equal to negative 2/3 x minus 4. So the first thing I need to do is identify the y-intercept. So my y-intercept is negative 4. So I can plot negative 4 on the y-axis. Okay, so if I plot negative 4 on the y-axis, I can then find my gradient, and when I look at it, my gradient is negative 2/3. So that means that I need to be going down from left to right, which means I either need to move down and right, or I need to move up and left in order for the line to fall correctly. So I'm going to go down 2 over 3, down 2 over 3, and then to get to the other side of the y-intercept, I'm going to go up 2 and left 3, and up 2 and left 3. And then I can connect those points with my line here. So that is how you graph in gradient intercept form. So now if we have in general form, we have to find our x and our y intercepts. So here I'm going to first find my x intercept by substituting y, by making y equal to 0. So when I substitute in 0 for y, I will end up having negative 9x plus 12 times 0 is equal to negative 36. When I simplify it, I will end up getting negative 9x is equal to negative 36. And when I divide both sides by negative 9, I will get that x is equal to positive 4. So my x-intercept is at 4, 0. Because when x is 4, y is 0. Once I do that, I will plot it on my graph. Next, I will need to find my y-intercept, which means that x is equal to 0. So I'm going to have negative 9 times 0 plus 12y is equal to negative 36. And when I simplify it, I will end up getting 12y is equal to negative 36. And then dividing both sides by 12, I will end up getting that y is equal to negative 3. So here my y-intercept is located at 0, negative 3. So when I plot my y-intercept, that is what I will get on my graph, and then I can connect it with a line. Okay? Some people graph general form equations by converting it to gradient intercept or slope intercept, and then just plot the y-intercept and use the slope, but it's doing unnecessary work. If you want to do it, you can, but it's not necessary. So that is how you graph equations of lines. If you have any questions, please reach out to me or your teacher, and have a great day.